This video is part 1 of 5 parts introducing trigonometry. The trigonometry that will be covered is the kind of trigonometry that would be done by a student in early secondary. Part 1 is about labelling the triangle. First of all, let's talk about the word trigonometry, though I think my diagrams fairly well indicate what trigonometry is all about. Trigonometry comes from, well, the parts of the words in trigonometry are tri, meaning 3, and of course triangles have 3 angles and 3 sides, and metry, meaning measurement, just like in geometry. So we're all about measuring triangles. In particular, in the junior secondary education, the triangles are always right-angle triangles. You can see this nice big pile of right-angle triangles here. So this first part of these 5 videos is about labelling the triangle. You must take care labelling the triangle. A lot of people think that this is, just something that you can do maybe if you want to, but it's not really necessary. But that's is incorrect, because if you don't label the triangle correctly, invariably you will make a mistake and your answers will be wrong. So you may remember labelling the triangle, the right angle triangle, in the other maths that we use that uses right angle triangles, which is called Pythagoras Theorem. And when you did that, you had to label the sides of the right angle triangle A, B and C. Well, we don't use A, B and C in trigonometry. We have new names for them, though we do start in the same place as we do with trigonometry, with Pythagoras, and that is identifying the hypotenuse. The hypotenuse is the longest side of the right angle triangle, and if you're not really sure which side is the longest side of the right angle triangle, if you make a little arrow out of the right angle, which of course every right angle triangle has, it will point to the hypotenuse. I recommend that you will always label the hypotenuse first. It never changes, whereas the other 2 sides are changeable. The hypotenuse is exactly the same side as you labelled in Pythagoras' theorem. You label with the C, it's the longest side of the triangle. Now the other 2 sides are called the opposite side and the adjacent side. Opposite and adjacent to what, I hear you ask? Opposite and adjacent to a particular angle that's marked in the triangle. Now at the moment, the marking that I've got in this particular triangle looks like a thumb, I suppose, or it looks like a piece of fruit. It's a circle with a line through it. And that circle with a line through it, I must admit it's not the neatest it could be, but there's no key on the typewriter that has that particular symbol. And over here you can see that symbol is called theta. It's one of the letters of the Greek alphabet. For some reason, most mathematicians and most maths textbooks refer to angles with the Greek letters, and they refer to other lengths and unknowns as the regular alphabet. So you might see questions with theta. Theta is my favourite, I must admit, it's one I use most often. But you might also see alpha, which comes from A, of course. It looks a bit like a fish, and beta looks like a bee that someone has lost control of their pen. So you might see any of these. There are, of course, lots of other Greek symbols as well. So back to this triangle over here. So every single right angle triangle will have either the angle marked in there or a placemaker, a marker for like theta marked in there. And then it's from that point of view that you're labelling the other 2 sides. So the opposite side is on the opposite side of the triangle to that particular angle. And the adjacent side, adjacent means next to, the 2 sides that are next to this angle are the hypotenuse, which of course you've already marked, and the adjacent side. So I like to imagine that I'm sitting in a triangular shaped room, and I'm sitting with my bottom in the corner, sitting on that angle, that theta. The 2 walls that I can reach out and thump with my fists are the adjacent and the hypotenuse, but the one that I'd have to get my tennis ball out and chuck it across the room to hit is the opposite side. Now, what did I mean by the fact that they change around sometimes? Well, have a look at this triangle. This triangle is almost the same shape, I suppose. And once again, the hypotenuse is in the right place, opposite the right angle. I've made a little arrow there to point to the hypotenuse. But now the theta is up here in the top corner. And as you can see, the opposite now is down here, where it was over there before. It's down here. It's because it always has to be opposite the angle. So you can't take a shortcut and say, okay, triangles that look like this, that are sort of pointing out here to the right, they will always have the opposite as the height and the adjacent as the base. It won't always be the case. It's all about the angle and not about the shape of the triangle. So here's the opposite side and here is the adjacent side. Okay, let's take a second to see whether or not you got that concept. Here are two triangles. I've named the right angle, and I've put a little theta in two angles, two corners, and I would like you to pause the video, and I would like you to take a second to see whether or not you can label the sides of those two triangles with O for opposite, H for hypotenuse, and A for adjacent. Pause the video. Okay, let's have a look at this. So the first thing we're going to do is we're going to look at finding the hypotenuse, and if we're unsure, we're going to make a little arrow down here on the right angle, and here it is pointing to the hypotenuse. We're going to plonk a H, whoop, not an A, an H please, an H there. Hypotenuse, well done if you got that. Then we're going to sit on this little theta there, and we're going to see what other side other than the hypotenuse is next to that one, and it's this side here. So that one's going to be our A for adjacent. Adjacent means next to, and our other one must be opposite. That's the one we need to get the tennis ball out to throw it at that wall. How did you go? Let's do the other one. So make a little arrow. Ooh, that's not a fantastic arrow, but you get the idea. A little arrow, it points to the hypotenuse. So we put an H. Oh, dearie me. Put an H over there. And then we sit on this theta and we think, what's the other side that's next to? It's this short side over here. So that's A, and the tennis ball one is O. How did you go? Well done. Don't forget to watch part 2 of this video where we learn about the 3 trig rules.